My name is Nadia Arafah, and I am a PhD student at Eastern Michigan University in Ypsilanti, Michigan. And today I'm presenting for you my research entitled of the effects of building envelope parameters on energy performance of high-rise commercial buildings. Sustainable building design attempts to reduce adverse consequences of environment, health, and comfort of occupants through enhancing the building performance. Based on previous research, one of the countries that demonstrated interest in sustainable design for the past few years and the member of the IPCC is the Kingdom of Saudi Arabia, a developing country that depend on renewable energy resources such as oil and gas for the most of their financial resources. Unfortunately, and with the urbanization status of the country, many buildings have been constructed with little or no concern of the extreme hot weather, which allows outside heat and air to penetrate to the building and increase the cooling load and energy consumption. The default approach for the occupants in such structures is to turn on the AC to overcome the heat almost all the time, which leads to higher electrical bills and the waste of renewable energy. AC systems in buildings in Saudi Arabia are responsible for 70% of the total energy consumption. Climate responsive architecture is a design practice that focuses on creating structures that serve side by side with the local climate, not despite of it. And according to previous research, designing climate-responsive buildings in Saudi Arabia is challenging, requiring an understanding of building materials and how buildings are designed, constructed, and operated. The process becomes more difficult with increasing thermal comfort expectations and the need of uh, premium indoor air quality. Complying with sustainable design standards at each phase in the building construction will decrease adverse environmental influences, increase occupant health, and help save money, which is aligned to the Saudi 2030 vision of sustainability. According to previous research, adopting sustainable design and adequately designing buildings envelope could save up to 60% of electricity, save 40 gigawatt per hour every year, and reduce electricity bill by at least 2 billion Saudi riyals annually, which is equivalent to approximately 530 million US dollars. The research design adopted in this study was an experimental quasi-research, uh, and the researcher digitally modeled and simulated an existing building in Riyadh, Saudi Arabia, which is the capital city. The building called the Olaya Tower A on July 29th of 2021, which was the hottest day of that year. The simulation of the current building design created baseline to compare energy consumption after changing the independent variables one variable at a time, and the energy efficiency target was set to comply with Ashur 90.1 2019 building code. The researcher obtained the floor plan of the building, and the building contains of 32 stories. The researcher picked one of those buildings and drew it by Revit and did the simulation by a carrier uh, hourly analysis program to study the research variables, which are R value, U value, sun heat gate coefficient, the VT, the air infiltration, wall window ratio, building orientation, sunshade device, on the independent variable, which was the energy consumption. Um, so the baseline of the R value was a wall structured of a heavily wall that has a R value of 8.93. The researcher presented three options and simulated the three of them and ended up that the option one of the lightweight wall with a 21 R value will save up to 0.22% of energy consumption. Regarding window U value, sun heat coefficient, and VT, the second option of the simulation process presented the optimum savings of 1.8% of energy consumption using gray reflective glass with argon uh, air infiltration. The baseline was at zero point 0.3. The researcher simulated four options, and option number one with 0.25 air infiltration, a value would save 0.8% of energy consumption. Window wall ratio, the baseline is 60%, which includes opaque and spandrel panels. Um, Option 3 of 24 ratio between window to wall would save up to 5.6%, and it is the best option between the three options presented and simulated. Building orientation. The current orientation of the building is at 24-degree north and 46-degree east, which is the baseline of this research simulation. The researcher rotate the building digitally and find out that rotating the building to 270 degrees would save up to 0.94% from energy compared to the base design. Regarding the exterior sunshade device, the baseline did not have any exterior sunshade devices. The researcher presented or added actually sunshade device louvers of three options of overhang. The option 3 with 8 inches overhang would present savings of 0.55%, which is the most savings potentials of those three options in the simulation. In conclusion, the researcher concluded that by altering those variables and choosing the best savings scenario, the building envelope will save cumulatively of 9.91% of energy consumption overall. This savings projection will line up with the Energy Star 2021 findings that stated that well-designed building envelope can make a real difference in utility bills, which will save up to 22% of energy consumption each year. Thank you very much for listening, and please let me know if you have any questions.